Time to learn about triangles, okay? You have to know these rules, you have to know these formulas. Please memorize it, know it in the back of your heart, and know how to use this to your advantage, okay? So let's go ahead and look at the triangle, okay? Before I go ahead and give you the formula, let's go ahead and take a look at a problem, okay? Let's just say I have this triangle over here. Here I have a 45, 45, 90-degree triangle. So here's my right angle, here's 45 degrees. Here is 45 degrees, and I say, hey, the hypotenuse is 4 radical 2. Find me the area, right? Find me the area. What is the area, okay? Let's just find the area first. Let's focus on that. How do you go ahead and approach this problem, right? I'm only given the hypotenuse, 4 radical 2. I don't know what my legs are. It seemed like a difficult question, except it's not really a difficult question at all. You have to know what the formula, you have to know that this is a special kind of triangle. It's a 45, 45, 90 triangle, and basically this is what you have to understand about a 45, 45, 90 triangle. It's that the legs are represented by the variable x, and the hypotenuse is represented by x radical 3. Okay, this is standard. You have to know this, okay? So this leg is equal to this leg, and the hypotenuse is x times radical 3. So how can we use this information to help us with this question over here, right? So let's just say this is question number 1. Okay, so well, here, look, this is, not x radical 3, x radical 2, okay? So right away, I've already made a mistake, okay? So pay very careful attention, not x radical 3, x radical 2. Memorize it, don't mess up like me, okay? X radical 2. Take a look at this problem, okay? 4 radical 2, right? It's very similar here. That's good. That means that this problem is going to be very easy. I know if the hypotenuse is 4 radical 2, my legs should be x. What's x? Right here, 4. So I know that this leg is 4, and I know that this leg is 4, and I want to find out the area. Okay, what's the area of a triangle? 1/2 base times height, 1/2 base times height. Well, my base is over here, which is 4, and my height is 4. Actually, the hypotenuse is not needed in this problem, so it will be 1/2 times 4 times 4, and you get 4 times 4 is 16. 16 divided by 2 is 8. Okay, now what if I ask you for the perimeter? Okay, very simple. Okay, you find the perimeter. You add up all sides. 4 plus 4 plus 4 radical 2. What do you get? So P is equal to 4 plus 4 is 8 plus 4 radical 2. And you have to leave that because you can't really mess with the radical 2 in this case. They don't combine, so you want to leave it as it is, okay? So here's a question, and this is a simple type of question, okay? Now, what happens if I, kind of play around with these numbers, okay? What happens if I gave you a problem like this, okay? So let's go ahead and separate this so you don't get confused and lost. Let's say question number 2. I have another 45, 45, 90-degree triangle. And in this case, instead of 4 radical 2, I just have 4. So the value of my hypotenuse in this case is 4. Well, now it gets a little bit tricky, right, if you don't know algebra that well, okay, or how to manipulate what you already have here, right? So I know that this is x radical 2, yet I have 4 over here. So I can't, it's kind of hard for me, right? I know that this is x, and this is x, and I know that this is equal to x radical 2. So what can I do, actually? Well, it's actually fairly simple. If you have this and you want to find out this, what you can do is divide this number over here by radical 2, right? Because if you go ahead and divide x radical 2 by radical 2, they cancel out and you get x, and we're good here, right? We're at a good standing point. So let's go ahead and do that. We have 4 over here, so I'll go ahead and divide 4 divided by radical 2, and now I'm left with 4 divided by radical 2. But hold on. Radical 2 is a disgusting number, right? You want to go ahead and rationalize the denominator, right? You want to go ahead and not leave a radical in the denominator because it's going to make this entire thing very messy. Because what if I asked you to find the area, right? It's going to be very messy. So what do? Well, go ahead and multiply both the numerator and denominator by radical 2. So that's called, when we say rationalize the denominator. And you basically take the conjugate. In this case, it's just one term, so it's very simple. But if I go ahead and multiply both sides by radical 2, well, what happens to the denominator? Radical 2 times radical 2 is radical 4, and radical 4 is a perfect square, which turns out to be 2. So it's very helpful in this situation. And then just the numerator is 4 times radical 2, so I have 4 radical 2, and I can simplify this, we already mentioned, to 2. So my answer here is 4 radical 2 over 2. Well, not my answer, but this is what x is equal to, right? So x is equal to 4 radical 2 over 2, and of course, this is also equal to 4 radical 2 over 2. And now if I want to find out the area, right, if I want to find out the area, what is the area of a triangle? Once again, area of a triangle is 1/2 base times height. The base in this case is this ugly number over here, okay, so 1/2 times 4 radical 2 over 2 times the height. The height is this, once again, also another ugly number, 4 radical 2 over 2. And now you can go ahead and solve this problem. 4 times 4 is 16. And then radical 2 times radical 2 is radical 4, which simplifies to just 2. So 16 times 2 all over 2 times 2 is 4. 4 times 2 is 8. And then there you go. You can go ahead and simplify the problem. 16 times 2, which is 32, over 8. Or just 4. Okay? So that's how you go ahead and do this problem. Okay, so now let's go ahead and take a look at another question, okay? What if I gave you the same triangle, but now I said, you know what? I'm just going to go ahead and give you the perimeter. The perimeter is equal to 8 plus 4 radical 2. 8 plus 4 radical 2. And I have a 90 degree here, 45, 45, and I'm telling you, hey, find the value of BC, right? Find the length of BC. So I want to find out what this is. I want to find out what this is. And I know this is a 45, 45, 90 degree triangle, so I know that this x and this becomes x radical 2, right? And now, how do I go ahead and solve this problem? I want to find out the value of this. I know that the perimeter is equal to 8 plus 4 radical 2. This requires some out-of-the-box thinking, right? Well, not out-of-the-box thinking, but you really have to just understand and use the values and things, that information that you're given, right? And you should know this formula. You should know that the perimeter is essentially side plus side plus side, right? So, I mean, over here, I also have these values, right? These are not values, these are variables, but what happens if we set these equations to each other, right? Because they should indeed equal each other, because here's the perimeter. I mean, given the perimeter, this is the perimeter of the triangle, right? So I can go ahead and make it into an equation. X plus x radical 2, and this entire thing is equal to the perimeter, and I know that the perimeter is equal to 8 plus 4 radical 2. So this makes perfect sense. Now, if I go ahead and try to solve for x, I can go ahead and actually find out the answer, okay? So I can go ahead, I have two like terms. I have one like term over here. X plus x, which is 2x, plus x radical 2 is equal to 8 plus 4 radical 2. And right away, you can see a beautiful relationship. You can see, well, I don't know, hopefully you've caught this, but here's a radical 2, here's a radical 2. Well, this is looking very similar over here, and here's the 4. So x over here is equal to 4 radical, well, the hypotenuse in this figure is equal to 4 radical 2. And then over here, what I know that here is 2x is equal to 8. Therefore, I can divide 2 by both sides, and x is equal to 4. So x is equal to 4. So the answer, right, my original question, what is the length of BC? That would be 4. But once again, it makes total sense because, hey, look at this. I can redraw the triangle. Here's a 45, 45, 90 degree triangle, 4, 4, 4, radical 2. It follows the standard rule that we have, right? That in a 45, 45, 90 degree triangle, the legs are equal to x and the hypotenuse is equal to x radical 2. So this is how you approach this kind of problem. So now let's go ahead and take a look at a 30, 60, 90 degree triangle. We've already looked at several examples over here for a 45, 45, 90 degree triangle. So hopefully you're actually very well familiar with these kinds of questions already. So let's go ahead and take a look at a 30, 60, 90 degree triangle. I do apologize for my triangles not being straight. So here's 30 degrees and here's 60 degrees. And let's go ahead and take up the initial information that you have to know. You have to know that this side, right, the side that is opposite of 30 degrees is equivalent to x, right? So this side is equal to x. This side is equal to x radical 3, right? The 60 degrees opposite side is x radical 3, and then the hypotenuse would be 2x, okay? So it's a little bit different. You should memorize this. You should know this. You should know how to use this to your advantage, of course, when given a question, okay? So let's go ahead and I won't give you such a simple problem now. Well, it's still simple, right? So let's just say I have another 30, 60, 90 degree triangle. Whoops, 30, and here's 60. 30, 60, 90 degree triangle, and I say the shortest side is equal to 5, right? The length of the shortest side is 5. Well, how do you go ahead and do that? Well, you should already know that this is the shortest side. If you don't know that, well, here's the smallest angle, 30 degrees. So the length opposite of 30 degrees will represent the shortest side. So in this case, this side will be 5, okay? And let's just say I want to find out the area, okay? I can find out the area, I can find out the perimeter. I'm just making up a question over here. What is the area of this? So here's a 30-degree triangle. The opposite side, the shortest side, is 5. And now I'm kind of stuck, right? If I want to find out the area, well, I know that the area is equal to 1/2 base times height. So at minimum, I need to find out this value, which I don't know. So this is not a 45, 45, 90-degree triangle where it's so simple because this 5 would be a 5 here. Instead, over here, you have to follow this rule. So instead of just 5, it's now 5 radical 3. So it's 5 radical 3, and now automatically I know well, let's just go ahead and do the hypotenuse for fun, okay? The hypotenuse is 2x. That means x is 5. 5 times 2 is 10. So the length of the hypotenuse is 10. And now if I want to solve for my original question, a is equal to 1/2 base times height. 1/2 times the base is 5 radical 3. So times 5 radical 3 times the height, which is 5, okay? So I have that 1/2 times 5 radical 3 times 5, and I can go ahead and combine that. So 5 times 5 is 25, 25 radical 3 all over 2. So that is my answer, which is the area of this figure over here, okay? If you want to find the perimeter, go ahead and try that yourself. For the perimeter, go ahead and try, well, not try, but add up all these lengths over here. So 5 plus 5 radical 3 plus 10, and then you can find the perimeter. Let's go ahead and take a look at another question. Let's go ahead and take a look at an important rule that you have to know. Let's draw it over here, I guess. Hopefully you can see it. Hopefully I have enough space. Let's just say I have this triangle, and no, it's not equilateral, although it looks equilateral. Forget about it. The scale is not. This diagram is not drawn to scale. And let's just say that this value is 11. This value is, let's say, 7. Okay. And now I'm going to ask you, okay, to find out the perimeter of this triangle. So I'm asking you to find the perimeter of this triangle given that this side is an integer and it is the greatest possible integer. So forgive me that I didn't write this question down, okay? I'm just making it up as I go along, okay? So I'll repeat that if you want to write that down, okay? So here's a question. I want to find the perimeter given that this length is going to be an integer, but the greatest possible integer, okay? And why am I doing this way? Why am I asking that? Because you have to know this kind of question, right? This question appears frequently and is tested. Basically, so this is x over here, and it's saying you have to go ahead and know this rule that this side cannot be less than the difference of these two sides or greater than the sum of those both sides. So what does that mean? Well, 11 minus 7 is 3, right? Well, 4. 11 minus 7 is 4. That means that x cannot be less than 4. So x cannot be, well, x is greater than 4. Okay, so x is greater than 4. But 11 plus 7, which is 18, meaning that x is less than 18. Okay, that's the rule. So my question states that I have to have the largest possible integer, and the largest possible integer, well, it cannot be 18, right? Because it's not x is less than or equal to, it's just x is less than 18. So the greatest possible integer this can be is 17. So over here, I know that x is equal to 17, and now I can find my perimeter, 11 plus 7 plus 17, and I can go ahead and solve for that, and that would be your answer. Okay, so make sure you know this type of problem, or more specifically, know the rule that when you're given two sides, the third side of the triangle cannot be less than the difference of the two other sides, or greater than the sum of the two other sides. That's very important. Okay. Thanks for watching the video. Please be sure to check out our book on Amazon. It's a specialized high school test prep book. This book comes with 5 full-length exams with answer explanations along with a manual to go ahead and better prepare you for the exam. You will find the link on the video or in the description above. Have fun studying!